Now you can see my presentation, Thomas, and everyone?
Yes.
Yes?
Yeah.
Okay.
Yes.
Yeah. So, yeah, good morning, everybody. Thank you for coming to this side event this morning. I would like to introduce you the research project named NUNATAK. In the next, yes, in the next slide, we can see the introduction about this issue. The climate change is one of the most important environmental problems of the 21st century, and human activity is mainly responsible for it. And the environmental pollution, especially aerosols, contribute to an exacerbated effect of climate change. In special, aerosols can be transported from the city to glaciers and be deposited, increasing the rate of snow melt, accelerating glacier mass loss, and affecting local and global climate. The question that we are trying to answer are the following. Is there pollutant transport from urban and industrial zone to mountain glaciers? We will try to differentiate, in this case, natural effect, wind, dry deposition, wet deposition, versus artificial effect, blasting, earth, movement, etc. Another question is, which one is the principal mechanism of pollutant deposition on glacier? Which mechanisms is more important, wet or dry deposition? It is possible to identify the origin of pollutant in glacier. We will try to differentiate anthropogenic source versus natural source. What is the effect of pollution on glacier? We will try to look at the effect on glacier surrounding local and global, and the effect over water resource. It is possible to mitigate the effect of pollution on glacier. In this case, it is possible to mitigate the pollution effect at the emission source or in glacier self and the impact zones. So we performed a bibliographic searching in the beginning for study related to the measurement of black carbon in the Andes Mountain, where very scarce results were found. But the increase in anthropogenic activity combined with a sustained economic growth in developing countries such as Chile results in a large energy demand, which is and will be satisfied mainly by fossil fuels consumption. We will inevitably bring as a consequence an increases of pollutant emission, such as particulate matter, organic compound, trace metal, and ions. One of the environmental components that can be affected are the glaciers of the Chilean Andes, where pollutant can be deposited, causing albedo decreasing, accelerated ablation, and glacier retreat. With this idea in mind, and in order to investigate the relationship between atmospheric pollution and effect on glacier, the NUNATAK Portable Glacier Research Shelter Laboratory were created, designed as flexible platform for long-term environmental monitoring in extreme areas such as the glaciers of the Andes Mountains. In the next slide, we can see the NUNATAK 1 installed 3,500 meters above the sea level in the high mountain school of the Chilean Army in the Aconcagua River Basin, where it has been operating without interruption since 2015. And the new NUNATAK 2 is installed at 2,500 meters above the sea level in the El Yeso Reservoir in the Maipo River Basin, where it has been operating since 2021. And we have here the laboratory facility in our university, while finally the atmospheric sample and those of snow, water, and soil are analyzed in our laboratory facility at the Federico Santa Maria Technical University in Valparaiso City, where we also have 2 air quality stations. The NUNATAK is designed and built to provide conditions of security, habitability, and thermal comfort for both instrument and researchers, with the following facilities: the desk, bed for at least 3 researchers, sleeping bag and mountain equipment, kitchenette, tableware, bathroom, heating, electricity, and Wi-Fi, winter and waterproof clothes, sampling material, bags, shower, glove, etc. The NUNATAK are equipped with autonomous photovoltaic energy system with several panels, a battery bank as backup power system, and charge controller inverter. And in addition, NUNATAK 1 has alternating current, and it uses photovoltaic energy for emergency case, guarantee a safe operation of all the installed equipment. And NUNATAK 2 will have current soon. But in the moment, we can operate it with the solar panel and battery. In the following slide, you can see the basic and standardized instrument that are installed in the NUNATAK and the snow and fire sampling system that we using for snow pit sampling and surface sampling of snow. Normally, we take in the sampling directly, directly on the snow place where we have the NUNATAK 1 and NUNATAK 2, and we take the sampling, and after the sampling, we transport the sampling to the lab for the next step, that is the analysis for chemical speciation. We have in this slide the different instruments that we have, for example, aerosol laser spectrometer, that is possible with this instrument to measure real-time measurement of the concentration and site distribution of suspended particulate matter. Ethalometer with real-time black carbon and brown carbon concentration measurement. Weather station, the net radiometer that can measure incident and radiation measurement, also albedo, and the total passive system, that's a total deposition passive collector, that's a sampling of sedimentary particle matter and French snow. Some instruments, such the aerosol mass spectrometer, are installed during specific campaign depending on the purpose of the study. The rest of the instruments are permanently delivering data online in real time every minute approximately. In this case, we have this aerosol mass spectrometer from the firm Aerodyne, a snow high sensor, radon meter for real-time measurement, the atmospheric concentration of radon to assessment the planetary boundary layer, and EPAS has scanned the real-time measurement of gases and particles, and the wet-only collector that is automatic wet atmospheric deposition sampling for snow or for rain. In the following slide, you can see the analytical instrumentation to perform the analysis of inorganic and organic chemical speciation of the sample collected in the various monitoring campaigns and obtained in the mountain environments where NUNATAKs are installed. Very quickly, in short, we have several field equipment for real-time monitoring, such as GRIM, aerosol spectrometer, nanosites scanning mobility particle, microetalometer for field measurement, etalometer for laboratory measurement, SUD-scan model for filter measurement, HIM 6000 portable air quality monitoring for gases measurement and also for particle, and the aerosol chemical speciation mass spectrometer, portable X-ray fluorescence system for measurement element in field. And we have also equipment for inorganic analysis, for pH, conductivity, ions, chromatograph, and we have HPLC also for measurement organic and inorganic ions and molecules, and ECP-MS for measurement element. And we have equipment also for organic analysis, a different type of chromatographic system, GCMS with ATD for VOC measurement, and different equipment for analysis of our sample. To close this presentation, I show you some example for publication that we have obtained thanks to the result of the NUNATAK. You can see in this different publication different issues, and the reduction of snow albedo from vehicle emission in Portillo, snow surface albedo sensitivity to black carbon, radioactive transfer modeling, black carbon of atmospheric emission inventory, radioactive forcing impact by light absorbing particle over snow, etc. Yeah, that is work that we can making together with our collaboration partner in different institutions in the world. And the idea of this presentation is to invite you to make different cooperation projects with national and international partners. And in this case, the idea is to expand our collaboration and the use of data collected so far in the NUNATAK. The installation or donation allows new equipment to study atmospheric cryosphere interaction in the Central Andes mountain range in Chile. The intercomparison of atmospheric pollutant or pollution instrument, carry out our scientific internship in Chile to work on the NUNATAK's cooperation project, collaboration network, implementation protocols, for example, for the Global Atmospheric Watch or Global Cryosphere Watch Station, development of collaborative monitoring and intercomparison program, development winter-summer school in Chile using the NUNATAK data and the infrastructure in the Andes Mountain, or development different master and PhD thesis in Chile using the NUNATAK data and NUNATAK infrastructure. Now we have an open question and discussion for the finale of this side event. So how do you think we could establish cooperativities with us using the laboratory refuge, NUNATAKs and their data? But before we go to this open question and discussion, we have the possibility to look some data from the NUNATAK 1 that is presented for Florencia Ruggeri.
Hi, everyone. Can you see my presentation?
Yes.
Yes.
Okay. Well, I'm Maria Florencia Ruggeri. I'm a postdoctoral researcher in CETAM, and I'm going to present some results that we have obtained from the long-term operation of NUNATAK 1. In this case, I'm going to show you some result of the atmospheric black carbon measurements and the relation with the vehicular traffic in the location in the NUNATAK 1. In this case, I'm going to present data from 2019. Well, Professor Cereceda, he already presented the laboratory located in Portillo. Here you can see the in the map the location of the laboratory and with the Santiago city in the south and the Los Andes city in the north. This location has a characteristic feature that it is located in the access road that connects Chile and Argentina, that it has a high traffic density with a large number of car, buses, and especially trucks that circulate in both directions. And this road has a curiosity that is, it has a seasonal operating schedule because of the weather. During spring, summer, and autumn, the vehicular traffic is allowed all day, but in winter, in the austral winter, the June, July, and August, the traffic is allowed only during the day, from 8 a.m. to 8 p.m. So, and the traffic is also banned during moderate and severe snowfall events. So we take the advantage of this particularity of the road to study the variation of black carbon levels with the variations in traffic in the area. Well, the equipment that we use to perform this analysis are the multi-angle absorption photometer to perform the black carbon atmospheric measurements. It's a photometer that works with an active sampler that impact the particulate matter 2.5 in a filter tape. It's an optical method that measured the black carbon concentrations in a wavelength of 60 and 37. And we also perform some meteorological measurements like temperature and wind speed with a weather station. Both instruments are very reliable, so we have a long-term data from 2016 up to now. In this graphic, we can see the black carbon atmospheric concentrations, the hourly profile, the daily profile, average by hour. The main characteristic of the graphic is that in summer, in spring, and in autumn, max values are given during the night. But in winter, the max values are given during the day. And this clear reflect the vehicular pattern in the area. Because as you can see, during winter, in the night, levels are very low, and in the hour when the traffic is allowed, around 7 and 8, the levels increase rapidly, and it's almost constant all day. And in all the seasons, you can see like a depression in level during the afternoon. And this is related mainly with the meteorological conditions, because in all the seasons, the temperature have a peak in the afternoon and also the wind speed. So this is a condition that favorites the dispersion and the dilution of the emissions in the area. To explore the relation between the black carbon concentrations and meteorological and the vehicular traffic, we perform a multiple linear regression analysis relating the black carbon atmospheric concentrations that we measure with the number of vehicles that circulate in the road, and to reflect the meteorological condition, we take the PBL, the planetary boundary layer 8 data that we took from MERRA, the satellite data. Because the number of vehicles we have in a monthly basis, we we average all the variables in a monthly base. And we found a very good fit of the model, like black carbon in the like a linear function of number of vehicles and the PBL8. This is the equation that model this relation. We can see that the number of vehicles, it has a positive coefficient. That means that higher is the number of vehicles, higher will be the black carbon concentrations, and the PBL show a negative coefficient. That means that the black carbon levels that we measured come mainly from local sources, because when the PBL is higher, the levels are more diluted and the black carbon levels are lower. And if the main source were transport from the cities, for example, this relation should be positive, because a higher PBL, it's better for the transport, because allow that the black carbon comes into the area. And we also have a very good level of confidence for both predictors, for black carbon and for the PBL8. And finally, this is an example of a typical month of winter, with the different cases that we can have in a day. This is our daily means, and the blue bars represent the days with normal operations. Red bars represent days with no traffic allowed because of snowfall events, and the yellow bars represent some days when the weather only allowed traffic for some hours, restricted hours. And if you can see, the days with no traffic levels are significantly lower than the other days. And here we have like a hourly means in detail of some days. For example, A is June 8th. And we can see the light blue bars are the hours when the traffic is not allowed during the night, usually in winter. And we can see that how the levels arise during the hours when the traffic is allowed. This day, the 26th, traffic were not allowed all day. So all day the levels were very low. If you can see in the axis, the level of black carbon were very low and more constant than in the case of the normal operation. In this case, Jan the 28th, traffic were allowed only from 8 to 1 p.m. So you can see how when the traffic is allowed, the levels grow so very fast and decrease when the traffic is banned again. And well, this is all with this example. If you have some question, you can write it in the chat.
Ya, Tomás.
Okay. So far, we had two questions through the chat. The first question is from Julian Herman. He asks, which is the wavelength range of albedometer? That is probit, spectral, or total measurements.
Julian have a question about the albedometer. Hola, Julian.
Yes, hola.
Nice to meet you here. Yeah, the wavelength from the albedometer is in the UV, approximately from 350 to 4,000. Please revise, Florencia, that is correct? Is it from the UV to the
Yes,
infrared,
yes,
low infrared?
it is a net radiometer. It's not a spectral radiometer. It's a
Yes.
Equipansonen. We have the same instrument in both NUNATAK, Equipansonen CNR4, and the wavelength is from 300 to
350, yes.
to 2,800 nanometers.
Yes.
I think. Yeah.
This is a pyrgeometer and pyranometer. Is it from
Yes.
pyranometer for outside and for inside from the reflection of the snow? Yes.
Yes. Cover the thermal infrared spectral range, the pyrgeometer.
Yes, and our friend from the Universidad Castilla-La Mancha, Magín La Puerta, can explain the next experiment, or the next measurement that we can make in Chile in the future with a spectroradiometer that had in the university. Magín.
Yes, we have bought an spectroradiometer to complement the equipment in the NUNATAK platform. And this spectroradiometer also covers from 300 nanometers to 2,500. And we expect we can carry this spectroradiometer in the next measurement campaigns to Chile. This is a portable spectroradiometer, so we can use it for both NUNATAK platforms.
Yes, we have a lot of different experiment and campaign that we can perform it in the future in the NUNATAK 1 and NUNATAK 2 in order to estimate the different albedo problem that we have in Chile with the labs, with the light absorbing particle deposited of the snow, and we measure also the deep of the snow pit that we need to differentiate between the soil and between the snow pit or snow pack. No? This is our idea in the future with the measurement with the spectroradiometer. But in the moment, we can using the measurement for a long time that we have with this albedometer from the measure this range of wavelength that Florencia said.
Thank you. Thank you. Very impressive equipment. Thank you.
Thank you, Julian.
Okay, second question is from Zoe Fleming. She asks, is the data sent to database or then any public database? Do you use the SIM card or to send to data or analyze?
Hola, Zoe. Nice to meet you also. Yes, the data at the moment is not public. It's not so for any other database or it's not shared in the moment with the World Meteorological Organization or from the GAO or from the Global Cryosphere Watch. The idea in the future is to share the information with these agencies, with this institution. But the problem that we have discussed in another meeting, this problem about the data, because we have, what can I say, it's a dilemma about the data, because normally, when we make some different project, in special with the CONICIT or now ANID in our research system here in Chile, we need to sync some confidential data protocol, yeah, because the financial for this work is normally from different institutions. One in one moment is directly from the state, but in other place is from the private company or a mix between private company and CONICIT. Yeah? In this case, we have a different protocol to maintain the information in confidentially. Before that, we can use it for obtain different products from academic products. For example, patents or licensing or a trademark from different data. But the idea is in the future, after this process, we can dispose this data for the community. That's the idea, and to share with another institution like the Global Cryosphere Watch, for example, a global climate change agency. But in the community, when we can see some agreement to share the information, we can make the same. We can sing some agreement between the people that we participate in this workshop or in this side event, and we can share the information to obtain more publication, for example, or to make some analysis, or to compare the analysis that we have in the NUNATAK with another labs that we can find in another continent, for example.
Okay,
I would
thank
like
you.
to add something. Sorry.
Yeah. I just wanted to add that we've taken some measurements in the Andes, and we have a real trouble with the SIM cards because sometimes when there's snowfall, things freeze, and sending the signal is quite difficult. I wondered if you use SIM cards or satellites, or you just download the data regularly.
Yeah, one of the idea to have this instrument also in the Andes mountain and permanent monitoring is to compare the data from the satellite on the earth, on the in situ measurement, to compare the data from the satellite and to validate the data from the satellite, to use the data from satellite to remote sensing for expand our measurement in another part of glacier that we cannot measure with our instrument. That's the idea. No? Normally, the data from satellite not necessarily is enough accuracy, is not enough validated, and then can make overestimation or a subestimation of the concentration from different parameters, especially in the area of aerosols. And that is very important for us to validate and to compare the data from the satellite from data that we can measure directly on site.
And I would like to add something, that the question of Zoe, and another reason because we don't have the data publicly available yet, and is because, well, the main reason is the reason that Professor Cereceda said. Now we are working on publications of the data, but also now we are a few people in the lab working on this, and it's a lot of data process because we have the main amount of data like a raw data. So we have to process that data to put it in a repository. So we are working in a, I think that Zoe asked about that, because we download the data manually now. we go once per month approximately to the labs to download the data manually. And we are working in a platform to make this process automatic. And we are working in software to process the data automatically. And this, it's going to make easier the publication of data, because it's like, now it's like an artisanal job to download and to process the data. We are trying to put all that things in order to create a repository and a platform to see the data and to make it public.
Yes, yes. So this is a very important issue, that the data to have a repository and have ideally have an automatic system that we can from remote system acquire the data, and we can apply quality assurance and quality control process in our laboratory to validate the data, to extract the data that is outlier and so on. That is very important for us to depurate the data before that we can use it for publication and for scientific purpose. No? But we have in maybe since 2 years, we have an automatic system for acquire the data from meteorological station and from black carbon and from aerosols. But the system that we have installed in the NUNATAK 1, that working now 1 year, and after this year, we have a problem with the company in Santiago that acquired the data, and then we lost some data from this period, because the company in Santiago have problem with economic, so financial problem, and give us not a good service for this proposal. No? And then we have again to try, we say Florencia, to install a new automatic and remote system for acquire the data, without that we need to go directly to NUNATAK 1 monthly and NUNATAK 2 to uploading the data for this proposal. And that is a very financial an important cost that we have, and time, and obviously efforts that we need to make this data uploading from the equipment, but it's necessary now. More question?
Yeah. The next question. It's from William. You mentioned that they are portable, that is NUNATAK facilities. Are you considering moving one of them or to different locations in the Andes, or the idea is to keep them at the fit location for long-term monitoring?
Yeah, before we answer the question for Julian, I think it's a question for Mukunda, no?
Yeah, that this question already
It was in the same line of the question of Zoe about the availability of the data.
Yeah. Yeah, but about the question of Mukunda, we can working together with the data to compare data from the Himalayas and data from the Andes. That is a very good and interesting question. No? That is open. We can make it together some comparison about the measurement that we can make in both mountain range. No? And to the question for Julian, yeah, in the principle, the boats NUNATAK are possible to move from one place to another. We in the beginning we thinking that it's possible to have enough infrastructure and enough so security for the NUNATAK to transport with the helicopter. That is the idea. Then we beginning with our agreement with the army, for the Chilean army. But because the Chilean army have the only one institution in Chile that have a helicopter that can so elevate this heavy piece of metal that is the NUNATAK. The private company have helicopter that is not so enough to elevate this this amount of weight. That is the problem. But for another reason, we have so interesting data in the place that we have the NUNATAK 1 that we cannot move for this place to another place. That's what the problem. That we have so interesting results and so interesting so behavior from the black carbon and so from aerosol that's why so not so happy that we can move and interrupt the data from this temporal series of data. No? That is the reason why we know the NUNATAK 1 in the place of Portillo. But the idea in the initial was to move the NUNATAK from one place to another place, and that is possible now also. For the NUNATAK 2 was a new concept of design to facilitate the transport of the NUNATAK in comparison with the NUNATAK 1. That we, in the NUNATAK 1, we are integrated the instrument capacity with the so sleeping capacity, so the behavior capacity together in one so shelter. And in the NUNATAK 2, we separate boats. Now we have a module only for instrument, and we have another module for behavior, for habitation. And then when we need to give the infrastructure for habitation of habitability, we can put together both module, the module from instrument and the module for habitability. With in this case, the idea was exactly to simplify the movement of the NUNATAK for another place. Yeah? In principle, the Yeso reservoir, where we have the NUNATAK 2 in moment, is agreement in a project from CONICET, the name is FONDEF, and participate in this project different companies. One of the company that apport financial for this project is Aguas Andinas. This is a sanitary company that use the reservoir from Yeso for drinking water. Yeah, and that is just for this reason we have the NUNATAK 2 installed in this place, because we have in this place not only relevant information about the snow and aerosol transport and water quality and water scarcity. We have, in addition, we have security, because this is a private place that is only permits to go for people that working in the company and for people like us that we have an agreement with the company. And that is very important to protect the equipment, because it's a lot of money in the NUNATAK inside and outside, where the equipment is necessary to put outside for measurement, and that is important to avoid different so manifestation of terrorism from instrument. But in the future, we we have another offer in Chile to put NUNATAK. We have another offer in another region in South Chile, in the Glaciar Universidad. This is another very interesting place to put NUNATAK also, and in Araucanía, near the Villarrica volcano. This is another place where the regional government have interest to put NUNATAK to measurement, so same parameter and same so results. Maybe we can development for this proposed for measurement in different places. So a unit more small, more flexible, not so big the NUNATAK in the moment. No? But this is in the mind. Mm-hmm.
Okay, next question from Pedro Cid is to Maria Ruggieri. He asked, how do you expect to look the data after quarantine due to the COVID pandemic?
Hello, Pedro. Yes, this is a very interesting question, because, well, you are from Chile, so you know that here we have like an infinite lockdown, and it's in the NUNATAK 1, we have a very special situation because the border with Argentina has been closed since 2020. So the vehicular traffic decreased a lot. Only the truck are circulating for the road, and up to now, this month the border is going to open. Like, so we have been analyzing the data considering this, the decrease in the vehicular activity related with the black carbon emissions, and comparing with the patterns that we have identified previously in the normal operation of the road, and we could see reflected this the effect of the lockdown in the black carbon levels. So we are also preparing a publication about that, and we also included I presented the data from 2016, from 2019, but we have added the data from 2020 to the multiple linear regression model, and the data is always fit, the model always fit, including the data of 2020, because the traffic decreased a lot, but also the black carbon levels. So this, it's another fact that helped to prove our hypothesis that in this location, the vehicular traffic is the main source.
Thank you, Florencia. The reason I asked you this question is because many studies in the environmental science especially are using this unique opportunity to create a baseline without human intervention. And since you show your data that respond very quickly to increment or decrease of the signal of black carbon produced by human activity, independent of the variable for weather condition or wind and so forth. So this can be, as I said, unique opportunity to create.
It has been like a natural experiment. Yes.
Exactly.
Yes,
so
and it's
not everything is bad from the COVID, you know.
Yeah, and it's interesting because the border is closed, but trucks are allowed. The trucks that transport food and that kind of things. And the level of traffic of trucks has been the same that always. So, and the trucks are one of the main emission sources because are diesel engines. They have diesel engine. So it's like the black carbon levels decrease in the same percentage that the vehicular activity. It's interesting. We are also preparing a emission inventory related with the vehicular traffic, differentiating the kind of vehicle, the engine, the fuel, and all that kind of things are related with the black carbon measurements that we have performed in the area.
Yeah.
Thank you, Florence.
Pedro, that is a very interesting question because we have the opportunity in this case for measurement in Portillo and in another place in Santiago. We have using this opportunity to measure also during the lockdown for different compounds, and very, very interesting things. That is a very unique opportunity that we have to measure this different situation. It's special for background in this area, like say Florencia, in the graphic that we show in the last slide that for this presentation, we can looking during the day where we cannot, the traffic is not permits because it's the weather condition is very bad, then we can looking the very low concentration of black carbon. And that is approximately the background concentration of black carbon in this area. And then not only in this area, this is maybe in this altitude from Los Andes. No? And that is very interesting to have this value for considering in the background of the atmosphere between the interaction between the cryosphere and the atmosphere. And for another point of view, is in the world, it's very, very few places where we can have the combination of altitude, snow, mountain, and a very high concentration of black carbon, because normally, and accessibility, that is another very important issue. No? And that is the important, or the importance, because we have the idea to conserve the NUNATAK 1 in the time and not interrupt the measurement in this place, because it's very scarce in the world to find this combination of different situations, like, I repeat, altitude, mountain, snow, winter time, where we can measurement snow sampling and constantly source directly in the place where we can measure without problem with the detection limit of the instrument, a very high concentration of black carbon or PAH or PCBs or another compound that we can measure in this place, because it's the source is directly near the monitoring site. That is very important. In other place, in other mountain range, normally you can have altitude, you can have snow, but you cannot have the source near the monitoring place. Or the concentration is so low that you cannot so measurement with your instrument because it's below the detection limit. That is another problem. It's a very good place to make different experiments. So, the first result that we have in El Yeso, in another place in NUNATAK 2, show that the place is very low concentration of aerosol in comparison with the NUNATAK 1, because in this place the mountain range is more close. No? It's not so source near the monitoring place. So that is a good place to measure the opposite that we measure in the Portillo. More questions?
There are no more questions in the chat. Professor Cereceda, do you want to say something else?
Yeah, the idea is to have an open discussion about the possibility for the colleagues that we participate in this side event to have a different opinion about the collaboration possibility, cooperation, agreement, interest for install the different instrument in our NUNATAK to use this platform for measurement. So this is an interesting issue that is related between the atmosphere and cryosphere. Tomás have a very interesting research about the transport from Amazonas burning, biomass burning to the NUNATAK, to measure directly in the NUNATAK. And that is another issue that we can observation in the NUNATAK, the transport of very long range transport of biomass burning from Amazonas. And we have detected also the biomass burning transport aerosol from Australia from last year, that we have this very high fire in the Australia, and then we can measure this event in the NUNATAK 1, 2. Now that is another issue that we can also offer to use the NUNATAK for this global event, maybe in the future, global event that we can have very frequently in our country, like volcano eruption, we can maybe in the future measure also. No? So it's open the discussion about the possibility that we can make together. Nobody have interest to collaborate with us?
Yeah, I'll just add from we're taking measurements in Chile in the mountains, and maybe we could be interested in talking about the databases and the way we can send the signals, send the data. Maybe we could share experiences on that. And also I know of a group that are making an ice stupa, kind of like an artificial glacier in the Cajón de Maipo, and they as well are interested in how they can send their meteorological data to somewhere. So I think they might be interested in collaborating as well.
Mm-hmm. Thank you, Sai. Yeah, we can make in together some campaign and characterize the ice, corn, ice, or a fern corn from different places. That is also a very interesting thing that we can make in our labs. No? We have from a company the possibility to use a border I think it's for 20 meters deep. And then we can take also a core from snow in different places, and then we can measure also fern profile and identify the chemical fingerprint of this corn in different so level of the profile. That is another interesting issue that we can make it also for different place. Yeah. Encantado.
Yeah, great.
Some another comments or a question or a interest?
Hello, I don't know if you can see me. Okay. Can you hear me?
Yes.
Okay. Well, I am Mari Carmen Lecuna. I work at Polito. Polito is Politecnico di Torino in Italy. And I am a chemical engineer. So basically, I'm doing now postdocs, but during my PhD, I was working in the development of a portable generator of standards for VOC measurements. So basically, my experience till now have been focused on the generation and the handling of VOC, in general, reactive trace gases. But I mean, I have been recently following a bit of the aerosol measurements. So I think, I mean, from the point of view of engineering, maybe, or improving measurements, I think we could collaborate, because we collaborate with meteorological institutes. And we have been also working in some projects related to metrology for VOCs in environment, industrial. I don't know if you heard about MetClean VOC, METAMC, key VOCs. So yes, I mean, our background is more engineering than measurement, but I think it could be interesting. And I am from Latin America, I am from Venezuela, so it would be nice also to, in that sense, cultural sense.
Thank you, Mari Carmen. We have in our first measurement a VOC, total VOC equipment to measure in the NUNATAK 1. And in this time, we have also measured a very high level of ozone. And that is very interesting things in this place, because the high level that we have measured in Chile include Santiago, that is normally very high concentration of ozone, because it's a very big city where we have the precursors of the formation of ozone in the photochemical smoke. And then this ozone is transport. It's a mass of ozone transport from Santiago to Los Andes, north from Santiago. And we think is this mass of ozone is transport not only from Santiago to Los Andes, from Los Andes to Portillo. And then because we have in Portillo more radiation and that in Los Andes, because this is a more altitude, maybe that can explain the high concentration of ozone that we have. And then this is a very interesting question. Measure VOC precursors also in this place, in the Andes mountain. I don't know information. I have looking for information in publication about the ozone and VOC in the Andes, that is very, very scarce also. That is so a reason, because we have interest in measure VOC in this place. So inclusive in 2000, in last year, we have a measurement, the first intent to measure VOCs, speciation of VOCs using portable GCMS. Is a equipment that we can using directly in the field with different system using SPMI, solid phase microextractions system, for absorbing VOCs during one day or during one week, and then we can so less the system so passive absorbing VOCs, and then we can analyze directly in situ. The concentration that we have measured in this place was very, very low in this moment. But yeah, I think we can so improve more absorptions process during the day to improve the absorptions for VOC, because the concentration was very, very low. But we can intend measure the appreciation of VOC with using this GCMS, portable GCMS in situ measurement, different so sampling system. And for another place, we can using also maybe in El Yeso, so passive absorption in foam, or another absorption like XID or another absorption system for measure VOC. That is an issue that we have very interest. And for another colleagues from the side of phytopathology or phytoecology, people that working with plants have the interest to measure also the impact of this ozone in the vegetation. No? And that is another issue that is very interesting also, because we can so make a view more holistic about the impact of ozone, not only in the atmosphere cryosphere interaction, it's in the phytosphere, so interaction with the cryosphere and atmosphere. I think it's very interesting to have a collaboration with you and your group, and so open to make so in the future so collaboration with this issue. Yeah, thank you. Please, yes.
I have a question. Yes. So you said using microextraction, you did some measurements and found very low concentrations. But could you tell me more or less on what level? Is it like low ppb or even lower than that? It's like tens of
ppb. Yes, yes. Now we looking for Victor. Victor, you are here. Yes, you can maybe remember the species that we can measure in this measurement in this moment. I think we can looking for Tolol.
Yes, I'm here. It's a long list, but around 27 species.
Okay.
From 6 carbons or 5. But we have some breakthrough problems with the species of 5 carbons, up to low molecular weight pH is like naphthalene.
Okay, and
so
what about the standards used for doing those measurements?
Again, I didn't hear you.
What kind of standards do you use for these kind of measurements?
We have liquid standards of the pure compounds.
Okay.
It's hard for us to find gas standards. We know that gas standards is the best way to do these measurements, but for us here in Chile, it's hard to find it because they produce it in the US, for example.
Yes,
and they have very short expiration time, so they expire during the shipping to Chile. So we have been forced to use liquid standards to run our analysis.
Okay. Yes, I think that could be interesting because, I mean, as I said before, we developed a portable generator of standards. So
yeah.
That could be also something that would be nice to implement there. For maybe, I mean, the one I did was able to generate up to 4 species, but I mean, now that the technology is known, it's something that could be adapted maybe, so you can improve also like the accuracy of measurements.
Yes, of course, absolutely.
Yes.
Well,
Mari Carmen, does it from permeation tubes?
No. Mine is based on diffusion. So it's
For
usually
diffusion,
very
yes.
stable over time. Because I mean, and it's also very reproducible, and it's accurate because you can even make it primary, because if you have a reservoir of liquid that diffuses, you can actually weigh that over time and know what is the diffusion rate that you're generating. And
Yes.
I mean, from that,
It's a very similar system to our
Yes.
performance standard,
Exactly.
whose name Callion here for our portable GCMS, which is a diffusion standard. Very stable in time, yes.
Yes, it's very
Yes.
stable in time. It's actually quite similar. I mean, mine is transportable, but it was designed based on an existing system that is on the Italian NMI and also in the Dutch NMI. They have basically the same system. It's like a big bath. So you have a temperature that is very stable over time, and that gives you the stability of diffusion.
Interesting.
Yeah, very interesting. Very interesting. Is it similar that we have a artisanal system that we have built it here in the labs for calibration with this standard calibration mix that we have in liquid form. Yeah, this is very interesting. Then send us the information, please, Mari Carmen. Yeah.
Yes, I'll share. We'll keep in touch.
Thank
you. Nice to
Thank
meet
you.
Please, colleagues. Some other opinion or a comments or a interest or a do you see more comments in the chat, Thomas?
No,
I think no.
no more question in the chat.
Yeah. So I not see more comments, not so more interest to make her opinion. So another opinion or a comments or a question or an interest to collaborate, then you can sending an email. The information is in the web page or in the the invitation of this side event, and then you can sending free information about your interests or topics, or a possibility to make some collaboration with us, and we can see again in another workshop or a symposium or a seminar that we can organize together. I think the people from IGAC is interesting also to diffuse our initiative in the webpage of the different workshop or a work group that is under the umbrella of IGAC, and maybe through the IGAC it is possible also to make some contact with us. No?
Francisco,
Yes.
one detail maybe is there, but I haven't seen it. Maybe you may have a like sort of protocols for the different research group to share the use of the NUNATAK, or some way that they can access that. That can be useful because sometimes it's just part of a research project to have access to those facilities. In that way, they can collaborate with you and you.
Yes, good idea. Yeah, the people can send us, and we can exchange and share different protocols or ideas to make some specific campaign in the future. Yes, or a change of students or interest of students that can make some PhD program or some part of the PhD studies between us using the infrastructure that we have in the Andes Mountain and in our university to make always the analysis of the sampling. That is possible also. We receive a lot of different students from different university here in Chile, and also we receive students from the AAD program from Germany and from another student from Europe. Now, this is not problem for us to receive a student also that have interest in make some working here. Maybe in the future we have more stable sanitary condition that we can again travel between the countries, but this is in the past was very normal for us to receive a student from another countries. Yeah. So Thomas, you can maybe close the session when we have not more comments or a opinion.
There are no more questions, so we can finish this side meeting. So thank you very much for all of you for attending this side meeting. To finish, we endorse to all of you to the mail us to add anything else about the NUNATAK infrastructure to collaborate in the future issues about that. Thank you.
Yes, the recording of this presentation side meeting, we can loading in YouTube, and we can give you maybe Tomas, you have the email for the people that participate in this side event, né?
Yeah.
Yeah. Yes. Yeah, and we can sending the link for the YouTube recording of this side meeting for share the information, and we can put together maybe the presentation also that we have here in this side meeting showing. Yes. Okay. Okay. Thank you very much again for your attention and for participating in this side event, and we can see again in Chile, maybe in the future, and in the NUNATAK also. Yeah. Okay. Bye bye. Thank you.
Bye.
Chao, chao. Gracias.